Hey everybody, welcome to another Teardown video. What we've got today is some really old video production kit. This probably dates from looks like around the end of the 1980s, so sort of 88, 89. I believe this is sort of professional end gear. It's the type of stuff that would go into TV studios and that kind of thing. So I picked this up recently on eBay from my sort of favourite computer recyclers. I paid 15 quid for the two items, which didn't seem unreasonable. I didn't really expect to get this working, and indeed it's not. But that might change, because I think all I actually need is a particular disc for it and a cable to connect the two things together. So although I'm going to do a teardown on this, it's not going to be completely destructive. I want to leave this in a sort of working state, so I can maybe play with it again in the future if I can manage to get the system disc. So let's have a look around this and see what it's all about. Well, we've clearly got two parts to this system. We've got this big unit here, which is a very heavy unit, which is obviously designed to go into a rack. There's no user controls on this. It's literally just 3 status LEDs on the front and a bucket load of connections on the back. This is the controller for it. I would expect this to be installed not into a vertical rack, but face up into a video editing desk, so you can have sort of ease of access to this joystick and faders and adjustments and everything. It's also a primitive touchscreen as well. So these two items would have been remote from each other. This would have been tucked away in a corner of the room, and then this would have been actually on the video editing desk itself. Now you're probably already starting to wonder what this can actually do. And to be honest, I actually don't really know, because there's very, very little information on the internet about this. I've seen one website with a guy who's got one in Australia, but there's no information about what it can do, or even pictures of it actually working. I think it's fairly basic. It's not Quantel Paintbox territory. I think it's basically simple fades, wipes, transitions. Yeah, there's probably zoom and pixelate functions and things like that. I would have thought. As I say, until I can actually get this running, I won't really know. But it's certainly not as advanced as things like the Quantel Paintbox. So I think this was probably used in things like news broadcasts and chat shows and things like that, where you're just doing basic fades and maybe a zoom in and things like that. So the hardware is actually made by a British company, or it was made by a British company, called CEL Electronics. They don't appear to exist anymore. The company name is owned by a current company called Snell Group, which do make video production hardware and software stuff for the broadcast industry. So there's obviously been a connection there somewhere. Maybe they were bought out many years ago. As I said, this dates from sort of the late 1980s, but this was designed and built in the UK, and everything about it just screams quality. It's stupidly heavy. Everything is so well put together and so well made. I mean, the joystick on here, it's just you can. I mean, this is don't forget, this is made in 1989, and it's still, everything's on it is just absolutely lovely and smooth. And these are machined aluminium, knobs are aluminium. You can just tell that it was built to do a very, very specific job, and it was built very, very well, and it was built to last as well. I mean, I don't know what the expected lifespan of something like this would have been back in 1989, but I would have thought they would have expected 10 years of use out of it, I would have thought. So the two items we actually have are the P152B Universal Touchscreen Controller. This seems to be nicknamed Morris 2. I'm not sure what that is a reference to. I've done a bit of Googling, and then there is a French engineer called Maurice Leblanc who proposed encoding video in a raster fashion. So I wonder whether that's some kind of reference to him, or maybe it was the guy who started the company, I don't know. And the actual unit that does the actual video effects is the P164 Digital Effects Framestore and TBC. That normally refers to time-based corrector. Right, so if we have a quick look at the external parts of these two devices, and then I'll tackle it with the screwdriver, and we'll have a look what's on the inside. So if we have a look at the 152B first, we've got main menu controls here: VTR, FX, mix, seek, setup, and U. Obviously there's a bit of dirt on the FX button there, so that's it's obviously being used for effects quite a bit. We've got take, go, and stop. We've got a spin wheel here, which is a lovely damped rotary encoder with a nice machined aluminium knob. We've got 8 function keys down the front, and you can also see down here we have some LED emitters and receivers. So these form a matrix. This is your primitive touchscreen. So as you put your finger in various places on the screen, you'll break the beams and create a pattern that you can track and work out where your finger is. So on the other side we have the system disk, which is just a standard 3.5-inch floppy drive. That doesn't look original to me. I would have thought it just looks a little bit too new, actually. The design of it doesn't look like quite a 1980s floppy drive. It looks like more 1990s. So I wonder whether that's been changed. We've got three knobs on here. Again, these are machined aluminium. We've got 2 faders here, which are really soft and gentle. Work so well. And we've got the joystick here, which has it's actually 3-axis. So you have up, down, left and right, but you also have rotation as well. So you can rotate it clockwise and anti-clockwise by, what's that, 20 degrees or so. So it might be for pan and scan and then zoom, that kind of thing. Now you might have noticed that all the functions on here are fairly generic, and they don't really mean anything at all. I think the key here is universal on the product name. As far as I can understand, this is like a generic controller which can operate several different pieces of kit. One of them being the P164 effects thing. So to operate it, you would load the system in on the floppy disk, and that would match the unit that you're trying to control. So without a system disk, unfortunately, this doesn't do anything. Well, it does turn on. I'll show you that in a moment. It does turn on and give you a screen saying it can't load the system. So if we take a look at the back of the controller, we've got power input. We've got the type is P152B Morris 2, so it's obviously some kind of product code name. Main power switch on the front here. A fan with I noticed clean filter regularly, but the filter's just completely disintegrated. It's just hardly surprising given its age. We have an access panel here. This gives you access into the CRT, and then finally on the end here we have the plug-in cards which provide all the actual brains to everything. So here we've got 4 plug-in cards. One of them is titled CPU. It's got 2 serial ports on it. Then we've got CRT with another 2 serial ports piggybacked onto this card, but they actually connect to this third card here. We've got a video out, which I suspect is just going to be a mirror of what you see on the internal CRT. We've got a peripherals card with another 2 serial ports on. They certainly do like their serial ports. A GPI, well, I'm not sure what that is. And finally we've got floppy disk controller with disk 2, so you can obviously have a separate second floppy disk drive. Right, this is the main brains of the system. It's the P164 Digital Effects Framestore and Time-Based Corrector, model 38XP. We've got 3 lights on the front, power, video and remote. There's not really much on here. We've got the CL logo and 422 component 8-bit digital system. So here on the back we have a cooling fan. We've got a number of inputs here. These have got little rubber covers on them, so these don't look like they've ever been used. So these are serial in, serial out. These are part of out and in parallel, whatever that is. We've got a P177, so that sounds like it's another CEL device that can be plugged into this. Connection is called BIM, video and key, preview, background, remote power operation, so maybe allows you to switch it on and off remotely. Further over here we have video input 1, 2, 3 and 4. These are all in and out. Then we have composite outputs, main, auxiliary, black burst. We've got component outputs, which is YUV. We've got key input output, so these are possibly for chroma keying. We've got a reference in and reference out, so that's probably a sync. You know, if you're in a editing situation, you want all the cameras and storage devices and processing devices to all be synced together, so that'll be the sync that comes in. And we've also got another advanced sync there. I'm not sure what that's for. We've also got dub inputs here with some settings on it. I haven't really got a clue what all this is for. IP, don't know what that is. That's some kind of special connector. YC, OP, auxiliary something, panel and controller. Now I think that's the connection that would go up to the touchscreen controller. Unfortunately, when I bought this, there was no cable with it, but I suspect this is just going to be a standard RS-232 9-pin cable, so I could probably make that. And then last on the end here we have one called remote disk. So there's obviously an external disk, either hard disk or floppy disk option. I would have thought, given that this is the thing doing processing the video, this is going to be a hard disk option. We've got a thermal shutdown light and finally the on-off switch. Right, so I've just got this plugged in, so I'm just going to turn it on. You can actually see it start up. So it's just trying to read from the floppy disk now. It doesn't do anything more than that. You just get a message at the bottom there saying loading from disk, no floppy. So that's as far as I can get. There's another clue to the name, which is Myriad FX. Not sure what that means. I've tried googling for all these different things and I've not managed to find anything. We've got the old the address for CEL. We've got version 21.3 and a reference to the model number, which is P152B. So that's essentially it. There is nothing else. It doesn't do anything without this system disk, unfortunately. Right, so we're just going to take off the panels on the back here and have a look at the these cards that are inside here. There'll be a CRT in here, and we've got a fan, there'll be a power supply as well, etc. So we'll have a quick look. Okay, I've got all the screws removed, so we just need to take off these panels. Right, so in this middle section we have the small CRT and a controller board down there. We've got a little ribbon cable running over from this side, so I'll have the actual video signal on. Then to the left we have the floppy disk drive, power supply, and then buried in the back there we have the actual front panel controls. So you can see there the joystick. So if we take a look now at these boards, so this one is labelled FDC, so floppy drive. 7.4 series logic, and most likely a floppy disk controller. So this one is titled Peripherals. We've got expansion port, serial port 3 and serial port 4. The expansion port actually plugs onto this, which is literally just two serial ports screwed to this card. They don't actually do anything on this card. They literally just plug into this connector here. So this is the peripherals board. We've got some 7.4 series logic as always. We've got some GAL chips there. The ICs, we've got a ZN502E, which is a analog to digital converter. We've got a Rockwell R65C52P3, another one there, and they are both dual communications controllers, so they're probably running their serial ports. And the one up at the top there is a UM6522A, which is a versatile interface adapter, which it just has loads of useful functions like timers and interrupts and I/O and serial ports and things like that on it. We've got a few little bodges here and here. So this one's titled CRT. So this is the CRT controller. So more 7 series logic as in everything in the 80s. We've got a large device here, which is an EF9367P, which is essentially like a GPU. It's like a complete system to generate text, graphics for CRTs. Right, so this is the CPU board for the controller. We've got an EPROM. We've got some DRAM here. This adds up to 256K. We've got a GM76C28. That's a 16K static RAM. So given that we've got a small rechargeable battery there, that's probably keeping this running. We also have here a 32 kilohertz crystal as well, so presumably this keeps time. It'd be fairly logical for it to do so. We've got 2 serial controllers. We have a DMA controller, so that's probably partly running partly to do with the floppy disk. I would imagine that the floppy disk card writes the data off the floppy disk directly into the RAM. This device here is the CPU, a little microcontroller or CPU, which is based on a 6800. Right, I think we'll take a look at the main processor now. First off, I'll look in the back, which is where the power supply is located, and then we can take off the front panel and we can see all the processing cards that are in this. Right, so we've got an access panel underneath the all the rear panel inputs with 6 screws to take this off. So here we have a switch mode power supply with various connections running out over the place. We've got the power input coming in and an earthing point. So this looks like an off-the-shelf unit. So in the back here we have a back plane for the cards that are plugged in the front. We've got various coaxial connectors all locked in. These are all on like retention clips. In the back there you can see we've got a fan, and we've got a panel with all the connectors on. We've got a mains input filter, and then all the spaghetti wiring running to the back plane. Okay, now we'll take off the front panel and we'll have a look at the processing cards that are inside. So that's just these 3 screws on the top and 3 screws on the bottom. Nice little captive screws so they don't go missing. Here we just got a little LED display panel, which just does the status LEDs on the front. Then inside here we have a aluminium cover, and it says just here on this bit where you remove it, this air mask is essential to thermal management and must not be omitted. So obviously they've quite critical on airflow design on this one. We've got a few adjustment points. They're accessible through this panel. We've got 27 megahertz clock and phase. Just here we have 2.5 milliamp reference there. We've got a reset, some dip switches. That's the cable that runs to the front panel. We've got SC phase, burst delay. And then we've got a few adjustments here which are U gain calibration, V gain calibration, V offset, U offset, decode U gain, decode V gain, and Y AGC. Oh, and just under there we have 4 dip switches which aren't labelled. Right, so what we've got here is a number of plug-in cards, which obviously do all the processing for all this. When I first saw this, it sort of struck me that the blue indicates digital and the red indicates analog, but that's not strictly true, but I think it is to a certain degree. So what we'll do is go through each of these cards in turn, have a look at them, see if we can figure out what they might be. I have been and looked through these already in a a fair amount of detail. I don't really know what most of them do, but you can sort of gain a pretty good idea, a pretty good guess what they might be for. So we'll just go through in each one in turn and have a look at them in detail. Right, so the first board we've got out is SPF1. This is one on what I believe to be the digital side. It's got this blue designator here. We've got a fairly well detailed board. We've got it's written on here Cell Electronics Limited. It also says Luma on here as well. We've got a load of 7.4 series logic and some those are all either PALs or GALs, which are programmable logic devices. But obviously it's populated by these really large ICs. These are probably ASICs. They are labelled CEL KABOC, KABOC. So these are presumably custom silicon that they've had made for this. But all these are identical chips. So this is the SPF2 card, the next one along. Obviously it's very similar to that first one we had. There's a few different layout changes. These are all the same ICs that were on that first board, so another 8 of those, and this one is labelled Chroma. There's a couple of bodge wires just here. So the next card we have is titled FSM. I think you probably make a pretty good guess what that is. Framestore memory. We've got a whole row of memory ICs here, and there is another of these boards as well, which is absolutely identical. So the memory chips they've used on here are Gold Star GM71C464-10. So they're 10 nanoseconds. They are 65536 by 4-bit. So that ends up being 262 kilobits per chip. We've got 16 chips on each bank, so we've got 1, 2, and then another 2 on the second board. So if you add that up, that works out to 2 megabytes of RAM in total. So we got 512, 512, and then doubled again on the second board. Also here we have some more custom silicon, or at least custom marked. We've got National Semiconductor logo there, and the CEL and M4-1 designation on it as well. So either these are custom designed by National Semiconductor for CEL, or they're just they've put their part number on them. So these are probably DRAM controllers to do all the stuff like DRAM refresh, all that sort of stuff. So the next board we have is titled BB02. Not really any idea what this board is for. There's a whole load of 7.4 series logic as usual. We have another custom cell device here. This one's labelled CEL SX-8. So I'm not sure what that might be. We've got some programmable logic devices, GALs or PALs or something. Some dip switches, some more dip switches here. Some little jumpers. And the next board we have is titled IoT. Now I believe this is some kind of communications control, some I/O. We've got a number of, we've got 1, 2, 3 EPROM devices on here, a load more programmable logic. So I'm not really entirely sure what this board is for, but I'm guessing, given that it's I/O, that it's some kind of communications board. Okay, this board is titled CPU, so no guesses what this one is. I believe this is the sort of main processor that does all the number crunching. We've got two EPROMs here, and some more programmable logic here, more 7 series. We've got 4 devices here which are sort of half populated bank. These are static RAMs, so this is either could be upgraded or it's just using higher density devices than it was originally designed for. We have here a Texas Instruments TMS 320C25FNL, which is a DSP. So that's probably doing the majority of the number crunching. We've got two 3.6 volt batteries here. I'm not sure whether I would imagine those are going to be lithium, primary lithium cells. They are actually on a separate PCB which can be removed, presumably to allow you to change the battery if they go flat. So we've got a number of status LEDs here. We've got a push button switch, some dip switches, and quite a few little jumper setting options. We've got a small bodge wire just here. We have a crystal here, which is 40 megahertz, which is probably for the DSP. Looking at the data sheet for this, it does run at 10 megahertz. So, and it does also say that the input clock is always divided by 4. So I'd say that this DSP is running at 10 megahertz, which is not especially fast. Over at the bottom here we have a Rockwell dual communications interface, and we have an unpopulated device here. I have no idea what would go in there. Right, so we've moved on over to the next board, which is on the right hand side of the unit. This has a red designator and it's titled PM1. As I said before, I was putting this side of the system down to the more analog stuff. This isn't really analogy though, for some reason. I don't know why. Maybe I'm just making the assumption that red means digital and red means analog and blue means digital is maybe just wrong. So we've got 3 large ASICs here again. Now these are the same as the ones that we saw on the SPF boards. These are titled CEL KABOC, KABOC. So they're identical to those ones. So we have a total of 16 on the SPF1 and SPF2 boards, plus another 3 on this board here. This seems to be a slightly newer design. There's a lot more surface mount components on here, apart from these two large devices here, which are IDT71325A55P, which are 2K SRAMs, but interestingly they are dual ported. So I wonder whether this might be some kind of buffer between what gets processed and what actually ends up going out to the video. We've got a number of jumpers and settings here. We've got some dip switches at the front here. Now the next card along is titled BIM, and it's completely blank and empty. There's nothing on it at all, apart from 3 resistors. Now interestingly, this is actually located near a blank slot as well, which with nothing loaded into it. And the legend on the side of the case, here, it does actually have a legend relating to the card which is actually installed, and the one above it is called DIO, which is just here. Now this one is actually empty. The BIM board goes into this slot here. Now DIO, I wonder whether that might be some kind of digital output. You know, this could be around the time that SDI interfaces becoming more popular in the sort of video production world. So that could be an optional upgrade for future digital outputs. So next up we have the IVI board. Not really sure what this one does. Everything's pretty ambiguous on here. We've still got plenty of jumper options. Right, next up we have the board called ADC. So this is going to be analog to digital conversion. So this will take the analog video coming in from the back panel and convert it into digital. So we have a whole load of analog processing on here. You probably recognise this and this here. These are two delay lines. These are sort of the analog glass type. We've got a whole load of analog adjustments. We've got variable inductors, we've got 10-turn pots, we've got variable capacitors. I think it would certainly take you a lot of tweaking to get this working right. The amount of adjustment pots on here, you're going to have proper tongue angles, I think, to get this working properly, and a wing and a prayer, I think. So we've got three large, medium-sized devices here. These are analog to digital converters. We've got three of these. I wouldn't have expected these to be RGB. I would imagine these are YUV. So we've got three of those. They are almost identical. Interesting that these two are sort of a classic epoxy case, and this one is actually a ceramic one. So I wonder whether this has been replaced at some point. It also has a slightly different part number. These are MP7684JN on these two, and this one is the MP7684KD. What the difference is between those, I don't know. Maybe it's just packaging differences or something, but that one's certainly different to these two, so maybe it's been changed. 20 megasamples per second, 8-bit. And just over here we have a TDA 4555, which is a PAL, CCAM and NTSC colour decoder. And finally, the last board we have is called ENC, which is encoding, I would imagine. So this is going to be the conversion from digital back to analog to go to the outputs. Again, we've got a whole load of analog adjustments, 10-turn pots. We've got some voltage regulation here. We've got three devices which are TRW1016N7C8. That's a video DAC. So we've got three of those, again, for the YUV video. We've got a HD 44007, which is a sync generator. Right, well, I've just put all the cards back into the system here. Now, unfortunately, there's not really much else to see now, as I can't actually get this thing to operate. There's not really anything to see. I would love to get it working, actually. It'd be interesting to see what it can actually do and what it can't do. So if anybody knows anything about where to get one of these system discs from, or any information that might help, that would be appreciated. If anybody's got any ideas on the capabilities going off from what you've seen on these cards, I guess the more experienced of you out there watching might know a little bit more about what it might be capable of. I'd be interesting to hear about those, so leave that in the comments. That'd be fantastic. So I'm just going to leave this hanging around my lab for a period of time, see if I manage to get any answers on anything. If I don't, I'll probably end up just scrapping this. There is some detailed pictures of the boards and various bits and bobs on my blog site. which is at dexterslab2013.blogspot.co.uk. So if you head over there, there's be a section on this where you can see some detailed pictures of the boards and various other little bits. So I'll keep this here just in case I manage to get it working, and if I do, I will post an update video. Right, thanks very much for watching everybody, and I will see you on the next video.